Hello, and welcome to this week's show. Today, we're going to be talking about consciousness, specifically the quote-unquote hard problem of consciousness. You may have also heard this called the mind-body problem, the problem of the mill, but it's essentially the problem that describes the fundamental inability to describe what's going on in the brain to our conscious experience. So the person that set it up perfectly was Leibniz, and let's see how he set up the problem. Suppose that there be a machine, the structure of which produces thinking, feeling, and perceiving. Imagine this machine enlarged but preserving the same proportions, so that you could enter it as if it were a mill. This being supposed, you might visit its inside. But what would you observe there? Nothing but parts which push and move each other, and never anything that could explain perception. This thought experiment, with good reason, has captured the imaginations and faculties of many brilliant thinkers for the last 300 or so years. Once the brain was understood as something that could give rise to our everyday experiences, coupled with the predominant thinking about machinery and automata at the time, it seemed natural to relate the two, both brain and machinery, to try to answer the fundamental question of how and why experience is created by, and related to, processes in the brain, or parts which push and move each other, as Leibniz said. Leibniz's problem, also termed as the problem of the mill, or the hard problem of consciousness, appears to be hardly a problem at all. After all, he seems to be making a simple assertion. Even so, with a little digging and unpacking, we can see that there are indeed some problems, or at the very least, questions that his thought experiment raises. Namely, the thought experiment presents two questions. 1. What are the neural correlates of consciousness, assuming that they can be identified? And 2. Knowing these neural correlates, can we explain how they give rise to or relate to conscious experience? Indeed, this is no simple matter. Notwithstanding, and as I hope to show in this show, Leibniz's problem is akin to something like David Hume's problem of induction, a compelling thought experiment that presents more difficulties than it does solutions. Instead, if we were to solve this quote-unquote hard problem of consciousness, we must look to other fields and methods to both qualitatively and quantitatively explain a theory of consciousness. Let us begin with the first problem, specifically that of theoretically identifying the neural correlates of consciousness. We will return to the second problem, that of relating the neural correlates to our actual experiences shortly. Before identifying the neural correlates of consciousness, however, it is worth having a little discussion about what consciousness exactly is. There is no agreed upon definition as to what consciousness is. If you were to ask around, you would get many different answers. Thankfully, Leibniz's example provides us with a relatively concrete definition. In fact, he embeds it right into his problem. What we cannot explain is perception. Granted, this may be a simple conceptualization given what is known today about consciousness, but one can hardly deny that it is a fundamental conceptualization. Without perception, there couldn't be consciousness. The other bit about consciousness that is important here, but not fully baked into the problem, is the subjective nature of perception. Perception is essentially unique and experiential to all individuals. There is no one perception that is the same for all humans. This can be seen as akin to Thomas Nagel's question of, what is it like to be a bat? Essentially, in describing consciousness, we must be able to describe what it is like to be X or Y. To describe what it is like to be X or Y would be to describe the subjective nature of its experience. And this subjective nature of experience is an assumption of awareness. Conscious beings are aware of the subjective nature of their perceptions. The third point that is important to note is that perception is a construction of the total sum of many different processes operating in the brain to achieve a single, unified experience of, say, the color red. We know that the senses aren't passive recipients of the external world, and the simplest example of this are optical illusions. We create our reality. In sum, we can roughly define consciousness as subjective perception that is constructed on an individual basis from the resulting mental processes of said individuals. With this loose definition in mind, we can now turn to the problem of defining correlations. What do we mean by a neural correlate? This may seem simple, but it is important to get this right. If we don't have an accurate idea of what a neural correlate would be, then we have no accurate way of measuring them, and the 3-pound mass of stuff that is the brain would be just that, stuff. The easy answer to what we mean by neural correlate is simply this: some event in the brain that is most constantly conjoined to our subjective conscious experience. More strictly, The presence of some event in the brain, while holding all else constant, is causally responsible for the subjective experiences of consciousness. Another, perhaps less intuitive form of looking at neurocorrelates would be to examine the absence of some event in the brain and see its effect on subjective, conscious experience. Although less intuitive, this method has perhaps been the most fruitful at discerning where consciousness lies in the brain. In taking case studies of patients with brain disorders, we can look to see how the absence of some functional brain region translates to the distortion of conscious awareness. For example, damage to area MT in the ventral stream of the primary visual pathway would lead to distorted stereopsis, in turn distorting the conscious experience one might have of depth perception and movement. This can be observed behaviorally in difficulties that said patient may have in, say, filling a tea kettle, but is confirmed subjectively by asking said patient what their experience is in filling that tea kettle. An even more extreme example. Damage to the posterior dorsal brainstem, which is home of the reticular formation in the ascending reticular activating system, can lead to global loss of consciousness. More on this shortly. So problem solved, right? Not quite. Notwithstanding the enticingly easy solution just mentioned, it is the former manner of approaching the neurocorrelates of consciousness, that is, relating brain regions that are presently activated in relation to conscious experience, that will prove to be more robust in our ultimate understanding of the mind-body relationship. Case studies, which are full of confounds, can only get us so far in understanding how disparate brain regions, when connected, give rise to consciousness. After all, is it the lack of a certain brain region that led to the distorted consciousness, or the lack of that brain region in connection to another region that tells us where consciousness arises? These are only a few of the problems that have led to the focus shifting from brain-absent paradigms to brain-present paradigms, and thus we arrive at neuroimaging to determine those active brain regions in the processing of that subjective conscious experience. Before elaborating on neuroimaging, let me synthesize what has been reviewed so far, and how it relates to the problem of the mill. Consciousness is subjective perception that is constructed from various brain processes to form a coherent, unified experience of both external and internal stimuli. This is what Leibniz, without saying why, mind you, said could not possibly be explained by the pushes and pull of the mill, in our case, the neural activity of the brain. The correlates to consciousness can be looked at in two ways: brain-present and brain-absent paradigms. In the former, we relate brain activity that is present during conscious experience to that very experience. In the latter, we relate functional brain disorders that distort conscious experience. Together, these would be the operations of the pushes and pulls of the mill, again, in our case, the neural activity of a brain. Both have been useful in getting us a starting point about the underlying functions of brain events and processes related to cognition, but neither have yet to give us a robust picture of consciousness in the brain. As it relates to neuroimaging, the dominant thought was that it would ultimately solve the problem of the mill. If you put a conscious person through various imaging techniques, you should theoretically be able to point to which region is responsible for consciousness, ultimately explaining why it is so. Of course, as consciousness is realized to be more and more complex, so is our understanding of the brain processes involved. It is fair to say that most in the field of relating brain and behavior will not argue for a single locus of consciousness. Instead, consciousness is understood to be an integrative process involving many disparate regions working in synchrony to achieve a unified, subjective, conscious experience. Notwithstanding, the most obvious starting point would be to find a single locus from which we could start to plot this widespread connectivity. This is most evident when looking at patients in various degrees of consciousness, both in clinical settings and simply stages of wakefulness. The degrees range from, in clinical settings, to fully conscious, minimally conscious, vegetative state, and coma, while in wakefulness stages, the degrees range from waking to REM sleep to NREM sleep and more, for example, parasomnias. Brain imaging of the former degrees, that is, the quote-unquote conscious aspects of both clinical and wakefulness states, show globally widespread activation and connectivity across the brain for many tasks considered conscious. Conversely, many would argue that in the latter degrees, of both clinical and wakefulness stages, consciousness is progressively diminished. As mentioned earlier, this progressive degeneration of consciousness can result from either normal changes in the brainstem, specifically the ascending reticular activating system, or from more focal damage to these areas. But this brings us back to our issues with case studies. If we were to quote-unquote turn off the rest of the brain but the brainstem, would consciousness still arise? In other words, is the brainstem alone sufficient for consciousness? And further yet, how do we know that it isn't the connections between the brainstem and other brain regions that give rise to consciousness? So how does one move from looking at focal regions, such as the posterior dorsal brainstem, to finding full brain connectivity as postulated by something like Barr's global workspace theory? Briefly, the global workspace theory is best described as a quote-unquote theater of the mind, in which a spotlight on the stage illuminates what is available to one's subjective conscious experience. This is analogous to working memory, what is presently being attended to by the conscious individual. Everything that is outside of this spotlight/conscious awareness is unequivocally subconscious, but nonetheless an important contributor to the operations of the spotlight, with local processors analyzing specific components of the stimulus in parallel and feeding them to the spotlight at large. In other words, there are countless contributions, aka pushes and pulls, from countless unseen agents, that is, disparate brain regions, largely coordinated by higher order association areas, that overall contribute to the direction of the spotlight of attention, ultimately guiding our subjective conscious experience. As the external and internal inputs change, so does our subjective spotlight. To quote Barrs, this is the primary functional role of consciousness, to allow a theater architecture to operate in the brain in order to integrate, provide access, and coordinate the functioning of very large numbers of specialized networks that otherwise operate autonomously. Thus, the global workspace theory of consciousness makes some clear predictions as it relates to the neural correlates of consciousness. There are interactions between local processing regions in the brain, largely posterior ventral regions, and higher order association areas, largely anterior dorsal regions, that work together in synchrony to achieve a global, unified, subjective experience of consciousness. This has been empirically tested by many people, and as you can see, and as I mentioned earlier, when you compare activity for unconscious and conscious stimuli in a holistic fashion, you are able to see this local and global connectivity between regions. Unfortunately, due to space constraints and time, I cannot list all of the findings, but it is important to note that largely the prefrontal cortex and the anterior cingulate cortex, with all their interweaving connections, seem to be the most critical and specifically underlying this integrative global workspace theory. This is only a single theory supported by empirical evidence that leads to certain predictions about the overall wiring and organization of the brain to achieve subjective cognitive experiences. Although it is among the most popular and influential, it is important to note that there are other theories and other findings that suggest different regions altogether or a different mechanistic account altogether. Unfortunately, due to time constraints, I cannot get into those here. As I mentioned earlier, the search for the neural correlates of consciousness is highly dependent on what method is used to find the correlates, that is, brain present versus brain absent paradigms. It is also dependent on which mechanistic account of consciousness is employed. The upshot of all this, however, is that neural correlates of consciousness eventually can be identified, and as we move to more precise tools and measurements, as well as an agreed upon working theory of consciousness, then we can begin to sift through the specific regions and their functional connectivity. As of now, however, we can further the discussion by assuming that the neural correlates are quote-unquote out there and will be known to us eventually. The problem then turns to how it is that these quantitative regions relate to our qualitative subjective experience. And moving on to the second question, remember, relating the neural correlates to actual experiences, we are faced with still yet two more problems. For one thing, we must figure out a way to relate the quantitative brain events and regions discussed above to the qualitative subjective experiences that we as humans feel necessary to our conscious experience. Let us call this problem 2.1. The second thing, and perhaps the biggest problem, is the dissociation between what is being measured, that is, brain events, which is a quantitative measure, and what cannot be directly measured using the same tools, that is, subjective experience or qualia, which is a qualitative measure. Let us call this problem 2.2. On the surface, it seems as though problems 2.1 and 2.2 are the same, but there are some subtle differences. Let us take each problem in turn and flesh them out carefully. So now that we have a rough understanding about the potential neural correlates of consciousness, something that is undoubtedly quote-unquote hard science and measured quantitatively as such, we are faced with the problem of relating it to consciousness itself, which is undoubtedly not quote-unquote hard science and is measured qualitatively, almost entirely on self-report. Many have tried to relate these two, and many have found the problem difficult, usually because of the implicit assumption that I baked into the opening sentence. There is simply a fundamental difference, or dissociation, between the two things that are being measured. One is quantitative and relies on objective brain data, while the other is qualitative and relies on the trust of subjective reports. That is not to say that the two things cannot be discussed in tandem. If they couldn't be, then we would never have a holistic account of how consciousness arises from the brain. One way of combining the two is through running various so-called, quote-unquote, correspondence experiments. These are simple and rely on simple assumptions about the brain and its relation to experience. The assumptions are thus: there is an external world that gives rise to experience in the brain through inputs at spinal and cranial sensory nerves. The brain then interprets these inputs and relays its own signals via lower motor neurons of the spinal cord and brainstem, which is then translated to either the objective report of muscle contractions, say in skin conductance responses or behavior, or the subjective report of the individual, say in their verbal description of what they feel. The idea of the correspondence experiment is to independently vary both brain and external world variables. Check the subjective report of the individual, and then look to see which independent manipulation, that of either the external world, the brain, or a combination of the two, is most responsible for the changes in subjective experiences. As we repeat this and, for instance, find a main effect for external world, then we can confidently say that the subjective experience is best determined by inputs from the external world and that the fixed brain simply interprets them as such. Say we find a main effect for the brain. Then we see that it is indeed the brain that these subjective experiences are reliant on and not the external world inputs. As to not complicate things, let us move from the hypothetical to the empirical. Relying on case studies, again, we know that variations to the brain are ultimately what result in variations in consciousness. After all, brain damage to certain regions, say the prefrontal cortex, would lead to widespread changes in conscious experience. Remember the examples earlier related to area MT or the reticular formation as well. As such, we must look to activities in the brain to explain the qualitative nature of consciousness, which leads to another solution, besides the correspondence experiments just mentioned, that can relate brain activity to conscious experience. What we see in the brain just is what conscious experience is. In other words, for example, the global connectivity and interactivity put forth by the global workspace theory and empirically confirmed by the other studies mentioned earlier can indicate a level of subjective conscious experience that is had in the person. That is, they can show that a qualitatively conscious experience is taking place based on the quantitative measures of conscious experience in the brain. This solution does, however, fall short in explaining what exactly that qualitatively subjective experience is. It only goes so far as to show its existence. Notwithstanding, to deny that the two are intricately related would be absurd. As I mentioned earlier, this is probably the biggest problem for the quote-unquote hard problem of consciousness. How do we cross the quote-unquote explanatory gap between the objective science of brain data and the subjective science of consciousness? How can we merge the quantitative data with the qualitative experience such that the former can explain the latter? We could take the correspondence approach mentioned earlier, or even the reductionist approach and call it a day. In the former, we have strong correlations between the quantitative and the qualitative, and that's the best we'll have. In the latter, the qualitative is just a manifestation of the quantitative. They are one and the same. These might be fine solutions, but ultimately don't refute Leibniz in his original assertion. We can scan brains all day, observe neural correlates of consciousness, etc., but in the end, how and why it is that the pushes and pull, quote-unquote, give rise to experiential qualities still remains unanswered. And I believe that they will continue to remain unanswered as long as we keep trying to compare objective, quantitative data to subjective, qualitative experiences. This may be what makes the idea of epiphenomenalism so attractive. Consciousness is like the steam rising from a steam engine, and we can no more explain, using mechanistic explanations of a steam engine, what it is like to be steam any more than we can explain, using mechanistic explanations of the brain, what it is like to be conscious. We simply know that they are inseparable, yet wholly distinct. In conclusion, we are essentially trying to relate apples to oranges. The apples, in this case being the empirical data, will never suffice in explaining the oranges, in this case being the subjective, experiential nature of consciousness. On the one hand, this is fine. Science isn't concerned with subjectivity or elusive and abstract concepts like the subjective nature of consciousness. On the other hand, a fully reasoned theory of consciousness should incorporate the two. We should be able to look at the brain states and infer the subjective experience, and vice versa. While we can look at brain states and infer that there is some subjective experience, it just doesn't suffice without explaining what that subjective experience is. So indeed, Leibniz's problem is a hard one, but not one that cannot be solved. I propose that we simply expand our theory of consciousness to go beyond the apples and oranges. Instead, we want a fruit basket that consists of art, poetry, philosophy, and all the other fields that can meaningfully contribute to the potential mechanisms that consciousness operates on. So, that's it for today. We appreciate you taking the time out to watch this video, and we hope you had fun learning something. Please stay tuned for the next couple weeks as we release more and more of these shows. Thank you, and until next time.